We'll summarize here the properties of exponential functions. Recall that an exponential function has the formula f of x equal a to the power x, where a is greater than 0 and different than 1. The domain is the set of all real numbers, and this is listed as the property number 1. The graph of the exponential function depends on the value of a. If a is greater than 1, then the graph will look like the graph on the left. Often we refer to such function as displaying the exponential growth. For example, the populations grow, showing this behavior. When a is between 0 and 1, the graph will look like the graph on the right. We often refer to such behavior as exponential decay, as, for example, the amount of radioactive material decays with time, showing this pattern. The points on the graph of any exponential functions are -1, 1 over a, 0, 1, and 1, comma a. And you should remember this when graphing exponential functions. We'll know the shape of the function just based on the base of that function, but to make it more accurate, we need those 3 points to be plotted first. The range of the exponential function is the set of all positive numbers. That means that the values a to the power x are always positive, no matter what x is, as long as a is positive. This also means that the graph will always be above the x-axis. The graph on the right shows that the graph is merging with the x-axis. This is just the limitation of the software that graphs such functions. Values of a to x are so small for larger values of x that distinguishing between the x-axis and the graph of the function is basically impossible. But you should remember that the values of a to x are always positive as long as a is greater than 0. The graph doesn't have the x-intercepts, and again, because of that behavior showing here on the right on the graph and on the left graph, we can conclude that the line y equals 0 or x-axis is the horizontal asymptote for that graph. When a is less than 1 and more than 0, the values of a to x approach 0 when x becomes larger and larger. When a is greater than 1, the values of a to x approach 0 when x decreases without bound. An exponential function is increasing for a greater than 1 and decreasing for a between 0 and 1. You can notice that increase, for example, when a is greater than 1, the increase is slow at the beginning, but then the function increases more rapidly. The same with the decreasing property. For a between 0 and 1, function will decrease rapidly. For negative values, when n increases from minus infinity to 0, and then the decrease slows down. An exponential function is also one-to-one. It passes the horizontal line test. No matter where I draw a horizontal line, that horizontal line will cross the graph of an exponential function at most at one point. Therefore, an exponential function has the inverse, and that inverse of an exponential function is called the logarithm, and we'll discuss the logarithms in the next lesson. Also, because of the fact that exponential function is one-to-one, we can say that if the values of the function are the same, so if a to the power u is the same as a to the power v, then u has to be equal v. If the values of the exponential function and two inputs are the same, then those inputs have to be equal. This is the definition of the one-to-one function. In words, we can say that if two exponents with the same positive base are equal, then their powers must be equal. And we'll use this property when solving some exponential equations.